Hello again, everyone. My name is Annie Cahill, and I have Becca Mangan with me from Datamark. And we are presenting in this class. This is our topology workshop. So, this is another new class that we are bringing to you um, for the state of Oklahoma. And in this class, we're going to talk to you about topology because topology is super important for NextGen 911 and getting your data ready. I think if you've been in any of our other classes, you've heard us discuss the importance of not only the relationships of a feature class, such as address points or road center lines, compared to each other, but also compared to the other feature classes that are used within NextGen 911. So today we're going to talk about the topology and what that means. All right, so let's start with talking about the concepts of topology. What does that even mean? That's kind of a strange word. So, topology really refers to the set of rules and relationships that define spatial relationships between features. So, what does that mean? It means that we are looking at the relationship between road center line to road center line. Do they snap and connect at a vertice? Do they, or a vertex, I should say, do they overshoot? Do they undershoot, which causes them to not be joined appropriately? Boundaries. Do boundaries fit together like the pieces of a puzzle, or do they have an overlap or a gap? And when we're talking about this in relation to NextGen 911, these things are very important and they have meaning. A road center line that's not joined appropriately to the adjacent segment can cause you to have issues with resource routing. You could also have things that occur during the call routing process, such as a misroute, especially if those ranges are not reflected appropriately. So, topology has a lot of implications for call routing for NextGen 911. The other thing is not just feature class, one feature to another within the same feature class, but also comparing one feature class to another. So for call routing, we want to make sure that we are really containing everything within the PSAP boundary and provisioning boundary. And I guess I should go ahead and mention, Becca, assuming that this might be someone's first class, the required data sets for next generation 911 within the Oklahoma state model are the PSAP boundary, which is the public safety answering point boundary, the provisioning boundary, which is basically the area of responsibility for that GIS data. For most of you, it's going to be your county boundary, also the individual ESBs, emergency service boundaries for fire law EMS. In the Oklahoma model, the emergency service zone ESC boundary is required, and the address points and road center lines. So those are the required data layers that are used to route a 911 call. And that's really what we're going to be talking about today. And we have some exercises kind of showing you those different things. So um, these relationships are critical for routing a 911 call. Remember that in NextGen 911, the GIS data is used to route the call. So it's not just used for a pretty picture, it's used to actually make decisions about how a 911 call gets to the PSAP. So it's really important that topologically our feature class relationships are solid, as well as the features within a feature class, right? So um, it does perform a function, and without having solid topology in your data layers, you can have incorrect results, system errors, operational failures. And I mean, an extreme example could be like, loss of time, loss of life through poor GIS data. And that's what we really have to focus on with NextGen 911. We can go to the next slide now. Okay, so common relationships, connectivity, how do features connect to each other? So as I mentioned just a few minutes ago, if you have two roads, adjacent segments that are supposed to be joined, but they're not. And by the way, when you look at this in a GIS, it might appear to be joined by the naked eye, but when you keep zooming in and zooming in, you might realize that the roads are actually not joined at all. This is a very common thing when you're looking at roads just without using any type of topology tool, it might deceive you. So the roads must join together, um, and have your, all of your vertices snapped. And really everything should be digitized in the same direction. And then, of course, for next gen 911, broken at intersections and where they cross boundaries. But a road network is definitely an example, where you would use topology. For any of you who have built a routable road centerline network, you know how important it is to have good topology for that to work, because that actually uses the road geometry and attributes to route something to a specific location. So that would be connectivity. Adjacency is basically how features share boundaries. So the most common thing that you guys are going to be working with would be your PSAP boundaries, your provisioning boundaries. Think about a puzzle and how the pieces fit together. You don't want intentional gaps or overlaps. You want everything to be congruent. So that's adjacency. And then containment really refers to where features exist inside of another. So I mentioned a minute ago the provisioning boundary. That's kind of like your cookie cutter. So everything that's outside of that is going to be ignored when that data is submitted up to your core services. So you really want to make sure that all of your GIS data, your address points, your road center lines, your ESB boundaries, all of that is completely contained within your provisioning boundary. Okay, so for Next Gen 911, we have super strict topology rules. And again, the reason is because we want this data to route a 911 call. You guys use your GIS data for different business purposes in 911, like we use it for our actual 911 system, we use it to reference as a map. But first and foremost, we need to get the call into the PSAP before it can be used for any of these other business needs. So we need to make sure that topologically we have requirements set on this data, because that's kind of like the final boss QC. And it's a part of the toolkit checks as well. So if you guys are using the Oklahoma State toolkit, this is a part of it. So topology definitely factors into those validations. So we do want to make sure that all of our topology is solid, and just understand that, while the state has its own standards, the National Emergency Number Association has its own standard from which the state standard is built. The next generation core services provider is going to have its own requirements. Your CAD system is going to have its own requirements. But improving the topology and making sure connectivity, adjacency, all of that stuff is preserved within the data is going to improve the overall quality for the data, no matter how it's used, for all of the business needs. I mean, I've never seen data that's been cleaned up that has not been beneficial for anything, even outside of 911. I mean, everybody benefits from super high quality and accurate GIS data.
Yep.
Okay, what are our requirements for our boundaries? So first of all, I already defined the boundaries that are required for Next Gen 911. Again, the ESZs are not actually used to route a 911 call, but the PSAP is, and the ESBs are also used as a kind of like secondary. And the discrepancy agency boundary, again, is really like your area of responsibility. It defines the geographical area for which a 911 authority is responsible for that GIS data. So topology requirements for boundaries, I mentioned before, you can't have gaps or overlaps because that has meaning. If you have an overlap, what that means is that the core services is going to just randomly select which PSAP a call should be routed to. And that is what we're trying to avoid with NG911. Remember that the purpose of NG911 is not only to improve that routing, but we do that through making sure that our GIS data is as accurate and complete as we can possibly provide. So it's to empower the locals, the 911 authorities who should be making these boundary decisions, to empower them to decide where to place a boundary that accurately and appropriately represents where a call should be routed. So we want to make sure that we don't have any overlaps. Um, we don't want any issues there with a call being misrouted to a wrong PSAP. And then of course with the gap, it could go to default routing just like within an overlap, but it also could mean that you don't get a call at all and it just goes into the gap. So we want to make sure that we are preventing any intentional gaps or overlaps. And luckily the tools within the toolkit, if you go and watch that video, we will review how those topology tools work within the toolkit. And also you want to make sure that basically all the boundaries are fully contained within the discrepancy agency boundary. You can't have anything that really extends outside of that as far as the boundaries go, because remember that kind of acts as a cookie cutter. And you also want to make sure that everything is fully within. Like you don't want any areas that don't have any type of coverage within the discrepancy agency boundary. So that's it. Becca, did you have anything to add for the
Mm.
boundary requirements?
No, that was a really great, thorough explanation.
Okay, great. So for address points, we want to make sure that they don't touch a road center line segment. They need to be fully contained within the boundaries. I think that if you've taken the topology class, you will learn that, or I'm sorry, the toolkit class, you will learn that a new field within the address points is a topo accept field, which does allow you to make an exception on an address point that occurs outside of the provisioning boundary. And I will reiterate in this class what I did in the toolkit class. I do not recommend that you try to maintain data outside of the discrepancy agency boundary because that boundary is the cookie cutter. And did I just refer to it as a provisioning boundary, Becca?
You did.
Okay, yeah, I got to be careful about that. So sorry, if you hear me use provisioning boundary, that is the term that Nina uses for the discrepancy agency boundary. So provisioning and discrepancy agency are the same thing. But um, my point is that you really should not try to manage any data outside of the discrepancy agency boundary. If you do, then I would mark those as an N in the submit field. So that way those data points or road center lines do not get validated within the toolkit. So that's really important. I know that it's allowed as a topo accept within the address points, but to me, there's no reason why you should be maintaining an address point that's outside of your discrepancy agency boundary if the address point belongs to you. You should examine that, make an appointment with your neighbor just to kind of talk through that and say, hey, who gets the call first? And then maybe you need to make a boundary adjustment. And we did also talk about that in the toolkit class.
Yeah, basically what you're saying is, and that I want everyone to know is there is an option where you can mark it as an exception where an address point may be outside the boundary, but that doesn't even matter because you can't provision data outside of your discrepancy agency boundary anyway. So it has to be marked as a no, and there's no real reason to mark it as an exception because it can't be accepted anyway, in a
Mhm.
nutshell. So what we're recommending is, obviously understand if that data is even needed to be in your data set. If it does, then like you said, mark it as a no for submission and just have it exist, right? But it's not something that would be represented for your PSAP data within the state system. All right. Anything else on these, Annie?
I think so.
Okay. Moving on.
All right. Road center lines. So for the topology requirements for road center lines, and again, think about this in terms of routing a 911 call, but also, for those of you um, who might build a routable road center line, the topology requirements are going to be important for you guys too. So, but for NG911, we need to make sure that intersections are accurately represented where you have traversable roads in the real world. So where I have a four-way intersection, I need to make sure that those roads are broken and snapped um, in those areas. We don't want to have anything that's self-intersecting where a road intersects itself. We need to make sure that, again, if it does intersect itself, like on a loop, that it actually is broken and snapped as well. Um, a dangle is referring to a road that just stops, whether it's a true dangle, where, like, for example, if you did not merge a road center line where it should have been, or where you have two segments that should be touching and they're not. Or it could also be something that's like a dead end or a cul-de-sac that could also be flagged as a dangle, such as in the Oklahoma toolkit, it does flag dead end roads as dangles. So you do have to go in there and mark all of those as exceptions. Um, Road must be single part. So you can't have a situation where you have one record that represents multiple segments. So every road has to be, or every road segment has to have its own record. And then we don't want stacked road center lines that cause basically overlapping road geometry. We want to make sure that that the roads are drawn individually, and that we, don't have any duplicates there. Um, Road center lines to boundaries, we want to make sure that our roads are fully contained within our boundaries, and that they are also broken and snapped to the boundaries. And this is not just referring to our PSAP discrepancy agency ESBs and ESZ boundaries. This is also referring to our municipal boundaries. So anywhere you have a road center line that crosses through a city boundary, for example, you need to make sure that you are breaking those at the boundary change, and then updating the attributes appropriately. And you will need to do the same within the address points as well. So if you have an address point that's located within a city, of course, the address point should carry the attributes for that municipality. And I don't know, Becca, if you had anything you wanted to add there.
The only thing I'll add is just a little foreshadowing preview. This situation about the stacked road segments is pretty prevalent within the state of Oklahoma, what we've found. And there's a lot of examples that we're going to talk through later in this video on how to best represent those roads in the situations where both segments need to be maintained in the data set. So more to come on that.
All right. All right. So for NG 911, the topology requirements for all of the data layers basically verify that, every address point and road center line belongs to one PSAP. You cannot have an address point that belongs in multiple PSAPs, because, again, the goal here is to support call routing. The service boundaries must be congruent. You cannot have overlapping or gapped service boundaries. Roads have to be fully connected and properly split at boundaries, as we just discussed. Um, Topology needs to support that address locations can be routed and validated correctly, and that ultimately the GIS data can be trusted by emergency systems. And that's why we have such rigorous requirements of this GIS data, so that it can support not only routing a 911 call, but also routing a resource like an ambulance or police car to an incident.
Right.
Okay, so let's talk about ArcGIS Pro and how it handles topology. So in order to run a topology, you must have a standard or advanced license. And we do talk about this also in the toolkit class. If you have a basic license, you cannot run a topology. You also cannot run um, the toolkit as far as its completeness with the topology, because it only works with a standard or advanced license. Um, Shape files are out. If you guys want to run a topology, you've got to make sure that you're managing the data in a feature class format that is managed within a feature data set within a geodatabase. So it's like a nested kind of structure. You have your main container, which is the geodatabase. Your feature data set is kind of the subcontainer that keeps all of those layers that participate in the topology within that specific container. And then, of course, the individual feature classes to represent those layers, which would be the addresses, the roads, and the boundaries that participate in that topology. So everything has to be within the same feature data set if you are going to make all of that part of a topology. And then, of course, they all have to share the same coordinate system. And if you've looked at the toolkit class, or if you're going to do that, the coordinate system is already selected for you when you go through and use that create geodatabase tool. I highly recommend that. It's going to make your life super easy.
Yep.
Okay, topology rules. What are topology rules? Topology rules are basically established to ensure that your data doesn't violate any of these rules, right? So we want to make sure, if we want to make sure that our addresses are completely contained within our discrepancy agency boundary, we have to make that a rule. Okay. Luckily, this has already been done for you in the Oklahoma toolkit. So all of the topology rules that are included as part of the NG 911 requirements for the state of Oklahoma are saved or stored within the README document when you download the tool. And I would encourage you, if you've never heard of the toolkit or don't know anything about it, I would highly encourage you to go to that video, because we show you where to download it, how to work with it. It's going to be super helpful for your NG 911 journey. But this actual screenshot is the list of rules that have been applied for the NG 911 GIS toolkit. And I will say that this one has not been fully updated because it doesn't show the topo accept for the address points. But again, I don't recommend that you actually utilize that. So this is a subset of possible topology rules that are out there. We do have a link here, and I don't know, Becca, if you wanted to show the poster, but the poster has a ton of
Mhm.
different types of topology rules. So we can
Let's
go ahead and
just
take a look at that. Yeah,
show, yeah.
I'll let you share that.
This has been around for many years. If you've been in GIS for a little while, you probably have seen this. But it's really just a visual poster that will show you the rules, all the possible rules that can be included in a topology for ArcGIS Pro. I think this is, we're not going to go through each of these, but if you're ever wondering, based on, one of these rules outlined in the toolkit, in the README, you can say, okay, what does that actually mean when I see must be properly inside? And it's a point to area comparison. You can come here to the poster and say, okay, well, where's, must be properly inside, must properly inside. Let's see. Shout if you see it, Annie. There's a must be inside here, and then there's must be properly inside. Okay, so we can zoom in there. So essentially what this means, just to give an example, is that a point has to be completely contained in the polygons, and it cannot touch the border of the polygon, and it cannot be outside. So that's the rule that the toolkit will flag for address points outside of the boundaries. So you can kind of get familiar, and this is really going to help you understand what needs to be modified in your data, because it's really important to understand the context. It's great that the toolkit flags it and the topology will point it out to you, but if you don't know why or what the actual resolution would be or what it's being flagged, then it makes it a little bit more difficult. But this is a great poster. It's got the visuals and explanations of all the possible topology rules. And I will say a lot of these are going to be required for NextGen 911 data. You already kind of went through it all, Annie, with like dangles, overlapping roads, intersecting, single part. There's all the different visuals and definitions here on this poster. Anything you want to add on this one, Annie?
No, just that I used to have this printed out and on my office wall when I worked in local government. So,
Oh,
yeah, you're
laminated,
right.
framed.
Yep, it has been out there for a really, really long time, but, and I think Charles may have formatted it to, like, make a booklet from it, so
Oh
if you
yeah.
need that one, then just reach out to Charles and he can get that
There
for you.
you go. It's the travel edition.
Mhm.
Oh,
Topology on the go. I like it.
yep. You never know when you're gonna need it.
This is true.
Okay.
Alright. Okie dokie. How to create one? Well, again, we've talked about what's required for that, right? So you need to make sure that you have a geodatabase and that you create a feature data set. The option will not even be available to you to create a topology without actually having a feature data set. So there are certain steps. We do recommend using the catalog pane to create that. You're going to get a wizard that helps you with the different feature classes. And again, if you use the toolkit, this is kind of already done for you. This is more of like a manual. If you need to create your own topology for, your own business needs, or you want more strict requirements of your particular data sets, then, you could go through this and, make your own essentially.
Yeah, and we're gonna walk through all this. And the good thing too, a lot of today in the examples we're going to show is how to do this manually. But of course, the toolkit has all this built in. And, if you were to go watch our toolkit training video, you'll see how that runs. But it is nice to know how to do this manually if you need to do something quickly on the
Yeah,
fly.
absolutely. All we have it all stepped out for you guys.
Yep.
So the final step is really to add the topology rules. And again, refer to that poster if you're really not sure about what's going to do what. The topology rules, that there's a lot, as you can see, and you may go your whole career and not use some of the ones that are shown on that poster, but the examples are provided here for you in the slides.
Yep.
And then everyone's favorite is the error inspector. So we're going to review that with you in this class and the exercises. The error inspector, I think we took a look at this in the toolkit class as well. It's a really great way to um, examine or step through any of those anomalies that are identified. I guess the topology errors, as they call them in Arc Pro. It's a great way to step through that and look more closely, because as I mentioned in the toolkit class, just because something is identified as a dangle doesn't mean that it's a true error. A true error would be where you have adjacent road center lines and it should go straight through, but maybe there's a disconnect between the geometry. That's something where you would need to fix that. But then if you have a cul-de-sac or a true dead end road, those would be where you would enter in the topo accept field to a dangle exception. So not everything is going to be a true error. You can use this though to examine and determine that.
Yep.
Okay, so topology within the toolkit. The toolkit video kind of goes into a little bit more detail, but the add topology is included within the enhancement tools. If you want to start off by, just doing an initial cleanup of that topology, you would run that through the enhancement tools. And again, go ahead and build your geodatabase, because when you use the create geodatabase tool, it will build the geodatabase, and it also will make that standards compliant with the appropriate coordinate system, as well as the appropriate feature data set that's called NG911. And then it works on storing the data within there. So it already takes care of that foundational piece for you. All you'll need to do is just run the topology from there. So you can either do it from the enhancement tools, or you can do it when you run the validations, because the validations will also do a topology run as part of that whole validation process. So the rules that the toolkit generates are the ones that you have to meet in order to have a compliant data set. And once you do, and once you pass through all the validations, that is when your data can be uploaded to the repository and into OK Maps. And I don't know if you have anything to add there, Becca.
No, I'll kind of be talking through this as we go through the exercises as well. So we can
Okay.
move on. Okay. Geodatabase and map topology. I can take this one.
Yeah, that's your favorite.
So start nerding out. So there are two topology options within the Esri ArcGIS Pro. The first one is the geodatabase topology, which is everything we've been talking about up until this point. It's the topology that you will create and assign the rules yourself. It is stored within the geodatabase. Like Annie mentioned, it has to be, your data needs to be feature class format, all within a feature data set. And the topology gets stored in that geodatabase. It's going to be applied to the feature classes that you choose to add to that topology. And it's whether or not they're visible in the map. So the rules are on the layers itself, not what is visually being displayed in the map. And you have to validate that and basically kick off that. You're managing the topology yourself, I'll call it. It also is persistent in that geodatabase until you were to remove it. So it can be created once and exist in your geodatabase and regularly validated as you continue to edit. And until you remove it from that geodatabase, it's going to stay there. It's obviously going to produce the errors, and you can use the error inspector to review and clean up and fix the data, which we're going to walk through here in just a moment. Now, the difference between a geodatabase topology and a map topology, map topologies are temporary and they exist in that current map session. So it's really something that the project is doing on the fly with the data in the map at that time. So this is really cool because it's not permanent and it will generate topology rules on the data that's in the map. And that can be from different data sources. It does not have to be in the same geodatabase within the same feature data set. It can compare data from multiple geodatabases. It can compare data from hosted layers, feature services, and it's something that the ArcGIS Pro software is creating a topology on the fly. I will say it does honor visibility in the map. So if you have layers in your map in the contents pane but not visible, or if you have definition queries on some of the data, the map topology will not apply to those layers that aren't currently any feature that's not displaying, I'll call it. So this is kind of an interesting one. It's not defined, so you can't go in there and explicitly say, I want it to show where address points are completely contained in a polygon. It's going to flag everything that it finds in the map in general, right? There's no validation required. There's really no management of this topology required by you. The product is doing that on its own. And I really think like this is the coolest part of it, is that you can have data pulled in from multiple sources and the topology is going to validate against those layers. So that's kind of important as we talk about down the road. In this video, we're going to talk about thinking of your data, your PSAP data, comparing it to your neighboring data. And you might want to validate the topology, but you don't want to have to add in the statewide data into the same feature data set to then create a whole new topology. You might want to use the map topology to tell you where things may need to be aligned. And so that's kind of the beauty of having this in different sources. The last thing I'll say about map topology is there are certain editing tools that will reference the map topology. So just a couple a line edge, which we're going to demonstrate later in the video, is a big one. And then there's other like standard editing tools that you can use with the map topology, like editing vertices, reshape, moving features. All of that can reference the map topology, and you can use that as you edit. So, in a nutshell, geodatabase, you have to manage yourself. It's stagnant. It's permanent in the geodatabase until you remove it. Map topology is on the fly, referencing the data in your map, and you don't really have control over the rules being applied. Anything to add there, Annie?
No, I would just say that the only thing, if you're kind of new to, GIS or, managing topologies or cleaning up the data, the toolkit, but, by virtue of the toolkit and how it's developed, it is a geodatabase topology. So I think for the purposes of these exercises, and this is an introductory topology course, I think it's great for you guys to know that these two exist. But for NG 911 and Oklahoma specifically, you're only going to be working with geodatabase topology.
Yep.
That the toolkit
Good
produces.
point. All right. Kind of already talked about this, but this is just a good little summary too. The use cases, map topology when you need quick alignment between layers from different data sources or geodatabases. If you don't control the schema, so if you're just pulling in data, and again, this could be even non-editable data. If I have a hosted feature service that somebody else is providing me, and I don't have access to that data, but I still want to see how my data plays, like topologically with it, you can use the map topology. And then, of course, if you're doing like short-term editing, because this map topology is with that specific pro project with the data in it. So it's not something that's going to consistently, it's dependent on the environment that you're currently working in. And then with the geodatabase topology, it's a long-term enforcement of those validation rules that you set. Multiple editors can access this topology because again, it exists in the geodatabase. You can share topologies too, right? So if you set up the rules and you want everybody to be following the same rules, when there's multiple editors, they can regularly validate their data or validate the topology and make sure that they're referencing those rules. And then, of course, when you are the one managing these authoritative data sets, that's when the geodatabase topology would be used. For the actual data examples, we have 12 exercises that we're going to walk through that will demonstrate different topology scenarios and tools to correct them. The first exercise we're going to walk through is how to just create a topology. So we've talked a lot so far about, what is a topology, and even in the toolkit, how that topology gets created and what the rules are. But we're going to show you how to actually create this by yourself manually in the geodatabase. So I'll kind of talk through the example and then I'll open up the pro map that I have ready. So the first thing we're going to have to do, and this is kind of step one, right? As discussed, the topology has to be within a geodatabase within a feature data set. For this example, of course, I have prepped data. If you use the toolkit, you will have the structure already created for you. So that's step one. Our data is already prepared. Step two is creating the topology. So what I'll do is I'll navigate to the geodatabase. I'm going to show how to create a new topology within a feature data set. And then step three is adding the rules. So these are the rules that we're going to add in this topology. We're going to demonstrate, or we're going to add the rule for a road center line must not intersect. Road center line must be single part, must be inside of the discrepancy agency boundary, where a road must be inside the ESZ boundary. And then we're going to flag gaps and overlaps within the ESZ boundary. After that, we will validate the topology, and then we're going to pull it into our map and start using the error inspector to take a look at the type of discrepancies that were flagged. So I have a map here just to give the lay of the land. This is already symbolized, as you can see. I have address points, roads, all of my mandatory boundaries. And as I zoom in, labels will appear. I have this all kind of symbolized and labeled to go through the exercises today. All right. So within my geodatabase, I have over here catalog open. In the geodatabase, within the feature data set, so this container right here, that's NG911, this is the structure that the toolkit would create. But you would right click the feature data set, go to new, topology. A window will open, the topology wizard, and here is where you can name your topology. So some people may want to be specific on, maybe it's boundary topology, maybe I'm focused on something. Obviously this will default with the feature dataset name underscore topology. I'm going to leave it as is. I'm okay with that. And then here's where I get to choose which feature classes are going to participate that I can develop rules off of. I'm just going to choose select all. And then I will say up here, there's a lot of default values already set for like cluster tolerance, things like that, ranking. I don't really mess with this. I feel like I let the software tell me the cluster tolerance. This is using the coordinate system of the data, so I let the technology kind of decide for me, but I wouldn't even know how to change these values if I'm being honest. So I leave those as is, and then the ranks as well. So once you have your feature classes selected, you'll go to next. And here's where we can start building out our topology rules. So you can either click in here to add a rule, or you can come up here and click the add button. So I'll do that. And now I can start defining, like these are drop downs. So because I chose all of the boundaries or layers to be included in as an option here, you can see my feature class list. So the first one, we're going to choose road centerline. That's feature class 1. And I'll choose the rule. So another drop down. Remember we looked at that big poster earlier with all the topology visuals? Here are all of the ones that would relate to a road. So as soon as I click rule, I get these options. The first one we had was must not intersect. So I'm going to set that. Then when I want to add a new one, I can also come up here, or I can just click and it's going to add a new line item. The second rule we wanted to apply was the road must be single part. Add another one where road, I kind of forgot which one it was. So we're going to do must not overlap. And let's do road must be, or must not, let's do must be inside. And now notice that this is must be inside is a line to area comparison. Previously, we had only one feature class or one vector type in parentheses here. That means there's one layer that's going to be validated. It's validating against itself. When you have the line to area, that means you need to apply a secondary feature class to compare it to. Because right now, you're saying a road center line must be within, but you're not telling it what to compare to. So feature class 2 is now available with the drop down. And notice how it gives you only the area type feature classes. And you can kind of tell here, this comparison is not something that would happen with an address point. Road's not going to be inside of an address point. So we said discrepancy agency boundary. And then we're also going to do, I believe road center line must be inside the ESZ boundary. Let's do that. Now I want to do a couple ESZ related checks. So my first feature class, this is just going to be validating where an ESZ must not have gaps, and an ESZ must not have gaps. So you can make a ton of different rules, and it's not super complicated or time consuming, but the beauty of this is you can save a set of rules here. So if I click save, it would save it as a RUL file, and you can name it, whatever your topology is named, or keep track of these so you don't have to build these rules again. And then it's as simple as loading in that file in a new topology if you ever want to have this kind of, I'll call it automated, but rebuilt without having to do the individual record creation or rule creation. Okay. The one piece of advice I'll give here is if you notice that your finish button is grayed out or your next button is grayed out, you probably missed mapping the second feature class in one of these rules. So always do a quick double check that you applied the rule appropriately. And that's why I pointed out what's in parentheses here. When you have a single type, it's going to be one feature class. When there's two, you need to have feature class 1 and feature class 2. So that's kind of a way to QC your work. All right, we'll click next. And I don't mess with any of this either. It's all the default. It's kind of just a summary. I don't change anything here. And we'll click finish. This doesn't take too long to create. If you watched the toolkit training class, you could see too with the toolkit tool, it only takes a couple seconds. Now, if I were to expand this and I don't see my topology in here, Pro tends to do this, but I recommend refreshing your geodatabase. So right click and go to refresh. And then once you go back in here, refresh the feature data set. There we go. When you do that, now your topology is going to be within that feature data set. So Pro kind of gets stuck sometimes. That's like a best practice is when you run a process or you're doing any type of data management process in here, just refresh the geodatabase or the folder, and the layer or whatever you're trying to see should appear. All right. Now that we have this topology, I'm going to right click and I'm going to choose validate. So we want to validate our topology, and now we're going to pull it into our map. So you can just grab it, and notice I'm still holding on to it. As soon as I drop it, good to go. If I did not have the feature classes in here that it was referencing, it'll pull those layers in with it. But since they were already represented, I just have my topology here. So if I turn this off and on, you can see topology is always in the pink Pepto-Bismol color. And it will identify all of the discrepancies flagged with the rules that I set. So polygon or area identified discrepancies will be polygon shapes. Line discrepancies will be lines. And if I had any point or maybe like dangle style validations in your rules, they would be points, dots on the map. So you want to start reviewing these, right? I want to know what is going on here, what's actually being flagged. In order to do that, you're going to go up here to the Edit tab, Edit ribbon, and you're going to choose here in the drop-down the topology you just created. So mine was named NG911 topology. Notice it says geodatabase topology here. The map topology is always there. It's going to live in here. There's nothing I can do. But this would not be here. The NG911 topology would not be here if I did not have it pulled into my map. So I'm going to choose that one. And now I'm going to open the error inspector right here. It opens up this other window, and it gives a full list of the errors that are flagged. So this should look kind of familiar with the topology that we just built. It'll have the feature class 1, the rule, and then if there is another feature class that's in question or causing the issue. I'll give you kind of a load rundown of what we're looking at here. So here's going to be the full list of issues flagged. Right now I have it filtered by map extent. So you can see there's 49 because that's what's visible in my map extent. As I zoom in, you'll notice these numbers reduce or change depending on the physical area of my screen. If you don't like that, you can turn that off. So just unselect map extent, and then you'll be able to see the entire count of issues in the data. This is interactive, so I could select this record here, and I can right click and I can zoom to. I can flash, and it'll flash it in the map. I'll do that again. And then I can select it. So when I select it, it's funny. It actually, let's see, select or unselect. So, well, I'll demonstrate that later, actually. Now, one thing I want you all to be aware of is this other window here, this preview. Now I'm going to zoom in here just so we can kind of see what's going on. So this rule or this issue that's flagged says it's a road center line that must not intersect another center line. So it gives you even the object ID of that road. So 323 intersects 324. Now, if I come in here in the map and I select it, there you go. There are the two features in question. So, excuse me. I'll clear that. Oh, that was my boundary, actually. Let me do something. I'm going to turn this off as selectable. So when I'm looking at an issue, there's a preview box over here where that it just kind of zooms in. So if I was zoomed out in the city, and this is, you can see, it is kind of a certain extent. But if I zoom in, this is my actual interactive map, but I can look at the details. It's not too descriptive, but it's just what is happening, what feature, what's being tracked or flagged. And then there's this fix option here. So I find this interesting, and I'll just say proceed with caution on this, but it gives you the tools that it's recommending to fix the issue. So if I were to click split here, it's going to actually do that correction for me. And that's great, but I personally like to know what's happening with my data. I don't really want to have this topology making decisions for me. So I'm going to discard that. I think that this can be valuable if you want some suggestions on what tools you might want to use to resolve a situation. So it's like, okay, yes, I realize I need to go find the split tool. Let me go find it in my tools up here and then perform the function myself. That's how I would recommend using this window. And then you can mark exceptions or clear exceptions. So let's talk about that really quick. This is not the exception that translates to the topo except field in the GIS data within the Oklahoma data model. This is an exception for tracking purposes of your topology. So it's really just a way to use this window of like, okay, I'm going to go through, sure, this here is a highway, and I'll even show, let's do some investigation here. This is like a highway segment. Maybe I don't actually want this to be split because they're not really on the same elevation level. And I want to keep that as an issue. So you can come in here and you can either right click and mark as an exception. You can do it from here. and notice now there's a tracking symbol to indicate that this record here is an exception. So that's why I'm saying you can use it as like a review tool. That's what I would recommend. So let's say you went through and you really only wanted to focus on the intersecting roads. You can add filters here to identify which records to look at. So let's say, yeah, we want to do must not intersect. There you go. So I have 10 of them. I just applied that filter, and now I can go through and review these all at once. You can kind of zoom to them, go through and mark them as exceptions if you need to, and just interact with this window however is going to be most efficient with your workflow. Okay. Let's do something. So I'm sure somebody is thinking, well, what if I set my rules, but I want to go through and I want to modify the rules that I apply to my topology? That's not a problem. Go ahead and do that. You can come into this topology within your catalog. If you just right click it and go to manage, that same window will pop up and I can go to rules and I can still modify this. So let's say I want to add a rule for where a road must not have dangles. So I can change this. I'm going to click OK. It's applying the changes. This is where that geodatabase topology is great because we talked about how it is a persistent thing until you remove it. You can modify this and it's going to exist within your data and revalidate. Speaking of, let's do that. Let's validate it. And as your data changes, you just have to revalidate it and it's going to flag the new discrepancies based on the rules that you have applied. Okay, so let's pull open the error inspector now. And let me turn off my address points. So notice now that I added that dangle check, there's a lot of pink dots. Dangles are one of those situations where it basically will flag, it'll place a dangle anomaly, I'll call it, wherever there's a road segment that has like a start or end point not connected to another segment. So you can see in the data, most of these are, yeah, this is legitimate, right? These are probably cul-de-sacs or, just dead end roads. They should not be connected. But if you ever see a pink dot somewhere on the inside of like a connected, adjacent roads, that is an indication that there's a vertex that's not appropriately snapped to the nearby road. So those are the dangles that you would want to fix. But the reason I'm pointing this out is with the error inspector, part of what you're going to have to do in the Oklahoma standard is flag roads that are an exception to the dangle rule. And that would be really all of these that we're seeing here, all of these cul-de-sacs. If you want an efficient way to do that, you could come in here and we can query or set the filter to only show where roads should not have dangles. And you can kind of do like a visual check and review, and then you can mark them as an exception. I believe you can do them in bulk too, mark as an exception. Maybe not. All right, I thought you could, but you can individually mark these as exceptions. And let's say you went through and you reviewed all of them. Knowing that this does not translate to the actual GIS data. So I'll open my attribute table really quick so you guys can see what I'm talking about. There's the mandatory field in the roads and now in version 3 in the address points as well called topo accept. Here. This is a domain and one of them is a dangle exception. So let's say I spent time reviewing all of these dangles, and I determine that, they're all exceptions. I can select these. I'm just going to do a selection, and I can click this button here, and it's going to select the features associated with these errors. So I'm going to click that. Now look at all those roads that just got selected. I've already gone through the effort of determining that they are exceptions. So I would recommend doing this process and then coming in here and in bulk applying the topo accept to a dangle exception. And you can do that using the attributes pane. You can field calculate, but just be aware that you need to know the coded value in order for that domain to apply properly. So I'll show you what that looks like with the attributes pane here. When you have records selected, let me move the topology. If you highlight the feature class name in this window, the edit that you apply in this, vertical attribute table, I'll call it, will reflect in every one of these 116 selected roads. So I'm going to come down here and I want you to watch the topo accept field. I'm going to come down here and change this to be a dangle exception. And now it just applied that attribute, that domain value to all of my selected records. So that's an efficient way of doing this process, interacting with the error inspector. So that is definitely a workflow I recommend. Other than that, like I mentioned, this error inspector is interactive. You can filter on it, zoom to the issue, and then there's also there's also the quick link tools right here, which is also what you would find in the fix window as well. So basically anything that you do by right clicking over here, you can find somewhere in this window. So that is creating a topology, editing a topology that you've already created, and interacting with the error inspector. So that's really example number one. I'm going to turn that off. And let's go back to our exercise. We're going to move on to editing. So the next exercise we have is intersecting roads. So this is a very common correction that's going to need to happen in everybody's data. I guarantee you everybody has at least one of these that's going to need to be split. And this topology issue is when two roads intersect without a proper break or an intersection created. So what we're going to do is we're going to use the split tool, and we are going to create an intersection. And the thing we're going to talk about is when you split a road, what are the updates to the attributes that need to be made? Okay, so let's go check out bookmark number 1. And I'm going to add my imagery, my address points, so we can see what's going on here. Okay, so you may notice already I have my roads symbolized where I have an arrow at the end point. So when I zoom in here, I know the labels are kind of blocking it, but you can see there's not an intersection for this road, but in the real world, it is an intersection. So I'm going to have to split this road at 2 locations in order for this to be topologically accurate. So we're going to use the split tool in the edit ribbon. It's one of the common used ones, so I have it up here in my favorites. It's right here in split. So once I select this tool, my cursor changes, and you're going to want to make sure you have your snapping turned on. So you can enable that up here in the edit ribbon. There's also a little spot down here in the bottom left where you can click on snapping. But it's really important when you're doing topology editing, geometry editing, that you have snapping enabled, because it's going to help actually resolve the issue and not create more. So when I hover my cursor over, my endpoint just naturally snaps. And that's what we want. We want to create this split where that road actually intersects this road. So the split is going to happen on the selected feature. So I have my selected road, and all I have to do is click once. And now that road is created. The tool is still enabled. I'm going to come over here and click here as well. So now I have 3 different road segments. I'll clear that. I have now, with my symbology, you can tell I have one segment here, and a segment here. So let me open up the attribute table. Now, when you split a road, or, there's other tools that cause this to happen, but when you split a road, it actually duplicates the attributes from that main feature that it split from. So right now, I'm kind of scrolling through the attribute table. There are a lot of duplicated field values across these 3 features that I do not want to persist. So end UID is one of them. My ranges are another. Depending on where the split takes place, you want to be mindful of the city values, ESN, MSAG community. There's a lot of fields in the data that we want to have be unique to each segment. So I can tell you right now, if I just created a split here and I left it, you're going to get some angry toolkit validation reports because you're making errors as you're editing and you're not editing effectively. Okay. So what I would recommend you do in these situations is you obviously maintain a unique NUID, but the toolkit can help with this. There's a tool that will generate that for you. The main thing I would recommend is coming in here and updating the range values to represent unique ranges, of course, but also the address points that are nearby. So in this case, I always like to have my address points labeled and visible, and I will look and I'll kind of go segment by segment. This one represents here. This seems to be the 16, maybe the 100 block. So I would have this updated to maybe 16,199. And then the next one, I would go to 198. Then I want to select the next segment, and we want to kind of increment up from there. So this seems to be the 200 block. I have 16,202. I'm just going to keep this as theoretical ranging. So you come in here, go 201. And this is a 200. And then the next one I want to make sure is appropriate. So it looks like we get into the 300 block over here. So I would just update the the 2 value to 299, 298. Now the final segment here is the last one. So I really only need to update the from values because I want the end value to stay. So this would be 301 to 300. So that is what you're going to have to do as you edit these segments to make sure that you are not creating additional discrepancies in your data, right? That was the split tool. Let's go on to, for the sake of this, I'll just discard. I'm going to save my edits. Always save your edits. You can auto apply edits within Pro. There's a lot of good tips and tricks in our introduction to ArcGIS Pro and transition to ArcGIS Pro classes. We also have recordings for those. So if you're curious on some tips and tricks using the Pro software, go ahead and watch those ones. Okay, let's move on to exercise 3. This is a multi-part segment. So what we're going to do is find the multi-part segment, and we're going to explode using the explode tool. It's kind of fun. If any of you guys are pyromaniacs out there, you can use the explode tool, and we'll talk through what that actually does. But just like using the split tool, what this is going to do is create a new feature. So we again would need to be really mindful of the fields that need to be unique to the segment. All right. Bookmark 2. So for those that don't know, a multi-part road is, or feature, is when you have two pieces of geometry merged into a single record in the attribute table. So if I turn on my topology here, I know that I created a rule that was for multi-part roads. So it's going to overlay here. So I could use my error inspector to identify these. But obviously I created this data, so I know it is right here. And I'm actually going to turn my boundary on so you can see. When I select this road, notice how this segment over here also gets selected. But in my attribute table, I have just one record. So I'll do that again. I could select this road, there's just one. I could select this road, there's one. But when I choose this segment, this piece of geometry also is selected. So we're going to come up here to the edit ribbon. And if you want to expand the tool gallery, you can click this kind of expand button down here. And it gives you all of the tools. The explode tool is in the divide category. So it's right here. So when I click this, it's going to open up a modification window over here. And really all I have to tell it is what road do I want to explode? And I just click explode. Now watch what happens to my attribute table. Now I have two records because these are separated geometry. But because they were previously a single record, it's going to derive the attributes from that original segment. So that's where these duplicated values will come from. Again, doing editing best practices, you're going to want to make sure that you have a good workflow to to maintain these values as unique. So the NUID, the range values, and of course, any of the place identifiers. So in this case, we actually exploded a road that is along an ESZ boundary. So you can see with my labels, here is 6216, over here is 6204. These segments need to have different attribution now. So let's go over here and take a look. So right now they both have 6204, which tells me this segment I'm going to need to update to have 6216. So you can do that, and that's for the left and right. So just be mindful again. Don't just actually I see I'm on a border right here, but don't just go through and start exploding things and splitting things willy-nilly. You got to make sure that as you make edits to the geometry, you're paying attention to the attributes associated with those records. The attributes for NG911 are just as important as the topology. Okay. Use your symbology and labeling to your benefit. You can tell right away. I was able to know with having my boundary layer visible with labels and these kind of thick borders, I knew right away that there was an attribute change that needed to happen here. So help yourself with some efficient editing techniques like using symbology and labeling. Really help. All right, save my edits. Okay, let's go to our next exercise. Exercise 4, bookmark 3. Now we're getting into topology where features are being referenced against another feature class. So road splitting on a boundary. What we're going to have here are two roads that, or a road that crosses a ESZ boundary, and we're going to need to split it. So let's go up here and let's go back to our map. And let's go to bookmark 3. And this is very common, these situations, and the intention of having left and right attributes of roads are to reflect the address points. So, and it's a rule of thumb in NG911 that whenever a road requires an attribute change, that road needs to be split. In this case, we are splitting on the ESZ boundary. Now, the ESZ boundary is a legacy layer, but we know that it does require an attribute change when it goes into a new ESZ boundary. So here's the road that's in question. It clearly crosses this boundary edge without a break. So we can see here too that we have address points, and let me do this because I always like to confirm against imagery before I do anything crazy. So these addresses seem to be accessible over here on this side of the road, whereas these are all over here on the north part. So when I turn that boundary back on, you can see when I do this split, I'm going to need to make sure that not only does the attribution of my segment need to be updated, but I have to make sure that my address points are also attributed appropriately within the proper boundary. So let's go back up here and split this road. So again, enabling the split tool. This is one that you don't need to do any type of like process. You just come in here and with the snapping turned on, again, see how it's, let me see, actually go. You're going to want to split that road right there along the boundary. So again, it's going to create another feature and it's going to duplicate those attributes. So of course you'd want to adjust the ranging to reflect the address points for this segment, update the ranging over here. But the scenario I want to talk about here is now I have two pieces of road segment in different ESZ boundaries. So some of you might be wondering, well, how do I need to attribute this road where it's fully contained, but maybe it's not coincident with the boundary edge? In this case, because all of the address points reflected off of this road are within 6216, you would make sure the ranges are updated and you would update the ESN and MSI community values if needed to 6216. And then that allows you to keep the consistency. So we talk a lot about this in the toolkit class, but the errors for the toolkit will flag if you have a mismatch of attribution between address points and roads. So that means you need to make sure that you are reflecting the attribution of the roads to represent the addresses. But what if I had an address point down here, let's say, on this structure? So I have a point here, but my road is within this boundary. So with the new logic of the version 3 Pro toolkit, you will have to make sure that you can have the left attribute of the road reflect these addresses, but also the right side, which is down here, reflect this address point. And unfortunately, with the toolkit validation, if the road is fully contained in one boundary, it's expecting the attribution of that road to exactly match the boundary. But what you'll have to do is make sure this road is actually coincident with the boundary in order to have a left and a right ESN value different. Okay, so you'd have to trace and align the road here, have the top part be 6216, and then the bottom be 6204 if there were address points down here that you needed to represent. We're going to talk about some tools here just in a moment to do that efficiently. Right, so that's kind of the thought process you need to have when you're splitting along a boundary. What attributes are going to be impacted, and how do I, make them unique, and just be mindful as I edit. All right, the next exercise is going to be stacked roads with multiple road names. So this is very common in Oklahoma, I'm finding, and it is not acceptable topology. We need to make sure that you do not have overlapping roads. That's also something that most next generation core services providers will not allow in their system. So it's just a best practice to do what we are recommending and the state is recommending as a pinch point. So what we're going to do is just simply use the edit vertices tool to create these pinch point roads at the intersection with parallel geometry. So let's go to bookmark number 4. Now it's probably hard to see, and I'm going to turn off some things here. But I have 2 roads right here. You can even tell with the labeling. 2 roads, both that need to stay in my data because I have address points up here for Main Street, and I have address points down here for East 590 Road. So let me come over here to my attributes and make sure I know which is which. So when you want to modify this geometry to have the pinch points, you're first going to want to select one record. So one road at a time. I have Main Street selected right now, and I'm going to reselect it. So basically it's the only road I'm editing. Main Street represents the northern part of this road. So I'm going to pull the road up. Okay. So I'm going to show how to use edit vertices to do this. I just select it, and as soon as I select this tool, you'll notice that all the road kind of turns into it's like almost X-ray vision, where I can see all the vertices of this segment. So there's a vertex right here and a vertex here. The red, just for those who may not know, the red vertex always represents the end point of a segment or a feature. So I'm simply going to just grab, I like to zoom in here because when you modify this data, you don't want it to be super inaccurate. You want it to still be true to the imagery. So I just have this vertex grabbed. I'm holding down on my mouse, and I'm going to pull it up to the right of way and have kind of an angled segment there. I'm going to come over here to the other side and perform that same process. Okay. See it there. All right. And it might be a little offset. We can kind of come in more here. Now, if you want to finish a sketch, you just click the check mark, or you can also right click and go finish. So there's one. And let's say I want to modify this next one now to be down here. Instead of grabbing those individually, you also can just grab the line in between 2 vertices, and it's going to modify everything in between those 2, if that makes sense. So I can kind of do this offsetting. Now, if you are OCD like me, you'll probably still have to come in here anyway and make sure that these are aligned and it looks good on the imagery. That wasn't too bad, actually. This side, see? So you can come in here. Now, here's a little trick. Because I am still in an active modification state, there's the original segment that kind of still has snapping enabled. If you hold down the space bar while you're modifying data, that snapping is temporarily disabled. So it allows me to change this vertex without it grabbing this road. So when I press spacebar, it's enabled. So there you go. So now I have my road geometry and topology. parallel with pinch points, not overlapping each other, and the correct sides of the roads are representing the address points. So even when you do this, you want to be mindful of the attribution. Of course, I want the ranging, the left range to reflect the address points. You know, obviously here it's already done, where the inside is 0, 0. The right side is representing these. And also, depending on what you're doing, be mindful of maybe some boundaries that you're editing against that could also change attribution. Okay. Let's talk about our next exercise. Bookmark 5. So this is the same scenario where we have stacked roads, but it's along a boundary. And I'm going to show you another tool to use for this situation. So instead of using just modifying vertices, I'm going to show you how to do reshape for this. Okay. So I'm just going to keep discarding my edits. This is bookmark number 5. I'm going to turn off my imagery, turn on my ESZ boundary, because I can see here, and I'll turn this off and on so you can see, I am along a boundary edge right here, which means that's another consideration you have to have. So there are stacked road segments right here. And this is a very similar situation to before. You want to modify the geometry to be parallel with pinch points meeting at the intersection. So I have 2 segments here. One of them is East Commercial Street, which represents this point. And then I have South 4215 Road, which represents this address point. So I need both of these to be existing in my data. So we'll do the same thing, and I'm just going to show how to do this using the reshape tool. So first select one segment. I have East Commercial Street. I'm going to reselect it. So now I know I need to have East Commercial Street over here on the right side to represent this address point. So simply use the reshape with that selected road. When you're doing reshape, you have to start and end the sketch on the selected feature. So I'm just going to place a vertex here. And I'm going to have my imagery because I need to know where the road is. And I'm just going to place, this gives me the freedom to re-sketch this road or reshape this road how I want it. So I want it to be kind of angled. I'm going to place a vertex here. And I'm going to come down to the edge, place another one here. And then I'm going to double click, and I'll kind of show you guys what this looks like. Double click to end the sketch. And there you go. It reshaped that segment I had selected with what I told it. So I placed my vertices, and now it's reshaped. So you can do the same thing with this segment now. I don't know if I have a preference here. I'm a big fan of reshape. I feel like I do it a lot and you'll probably notice throughout this video, I use it a lot in addition to other editing tools. So yeah, there you go. That's a little sharp, but you get the point. It's very simple, but you have to start and stop on the selected feature that you are reshaping, right? Now, again, we were along a boundary edge. So now that I've modified the geometry, you're going to want to be mindful of the attributes that could be impacted. So of course, I want to check out the ESN, making sure that the ESN value of this segment would be both 6204 because it's fully contained now in this boundary. And then on this segment, you would want to update your ESN to be 6216 because now it is fully encompassed within this boundary. Right. Let's go to the next. The next exercise is going to be for boundaries. So I love editing boundaries, and I'm not afraid to admit it. It is a guilty pleasure of mine. I get kind of made fun of by Miss Annie Cahill, but I don't care. I am proud. And there's a couple really cool tools I'm going to show you that can create some major efficiencies in your boundary editing. So this first exercise we're going to show is when you have gaps in a boundary, what is a really efficient way to fix those? So you're going to, what I'm going to demonstrate is using a combination of a couple tools. So autocomplete polygon is awesome. And I will show what that will do. And then we're going to have to use the merge tool. And then I'm going to show you an efficiency by doing a bunch of issues all at once with just a couple fixes. Okay. I know everyone is just so excited. The suspense. Okay. I'm going to turn off. So I strongly recommend when you are doing, especially topology for boundary editing, that you turn off anything that you don't need to be looking at. So kind of clean up your area so you know you don't have a bunch of noise as you're trying to modify these boundaries. So obviously it's pretty apparent. You can see these gaps, and I'll turn off. There you go, a little more clear. There are gaps all along this ESD boundary. I am going to show you how to fix one gap and how long it can take. But then I'm also going to show you how to do this entire area all at once with just a couple clicks. So I'll zoom in here to this gap. I'm going to make sure that my ESZ boundary is selectable. And I'm going to come up here to the edit ribbon, and I'm going to choose, excuse me, create features. So we're going to do we're going to use the autocomplete polygon. I don't even want to call it a tool because it's not in the tool gallery. It is within the create features window. And what this does is it's going to fill a gap within a polygon layer. It has to be within its own feature class. It can't be across layers, but it's going to fill a gap, an enclosed area, with another feature or another polygon and completely edge match this for me. So probably hard to explain, so I'm just going to show. I selected the create features. It opens up the create features pane over here. I'm going to choose the ESZ boundary. Again, it's my only option because it's the only one I have visible, and it's the only one I want to be editing anyway. Right here, there's in the second icon, it's the autocomplete polygon, and you can see the description. It says it creates an adjoining polygon using an existing polygon in the same layer to complete the coincident edges. So I'm going to select that, and all you want to do is place 2 vertices in this gap area, and I'm going to double click, and a new feature gets created that completely edge matches that whole gap area. It's awesome. Definitely recommend using this. You can use it for a lot of scenarios, but I wouldn't recommend. When you place your vertices, make sure you put it in that empty space and you don't grab one of these edges, because if you do, not only will it be creating 2 different polygons, because it's kind of like splitting this in half, it will create an additional vertice that you may not want along these edges. So just do 2 points here. And again, you can always use that trick by holding the space bar to temporarily disable snapping, and that'll help you out. So we have a new feature now that filled that gap, but the second step would be to merge that new polygon into the polygon it's supposed to be. So let's say I did the research and I know that that gap area should actually be encompassed within ESN 6204. Because it's a whole new feature, there's no attribution right now, which is why when you use the merge option up here, you want to have the 2 features selected that you want to merge. You select merge, and you come in here, and I like to flash the feature to preserve the attributes from. So we want the greater one. You can even see there's attributes filled, and then you'll just click merge, and there you go. So now we have a coincident boundary right here. That gap is completely filled. topologically correct, might I add. And, you know, that didn't take too long, right? I'm going to undo that and show you an even more efficient way to do this scenario all along the edge. I have gaps all along here. From here, I think there's like 7 gaps in total. Okay. I always tell people not to freak out when I do this, but just follow along and I will explain. So I'm going to be reshaping this polygon. So I'm going to select it because I know that the ESN 6216 is actually correct. And it's kind of this staircase looking edge. I want to align all of these gaps to snap to that edge. So I'm going to use a combination of reshape. So with this polygon selected, I'm going to use reshape. And I like to exaggerate this because I want to reshape this area and make a whole new single gap that encompasses all these little slivers. So I'm going to start on the boundary edge and I'm just going to place a couple points here. And I'm going to stop it for here. So now I've just created a bigger, more visible gap that covered or encompassed all those little gaps. And now I'm going to go back to my create window, select autocomplete polygon, place my 2 points. It autofills that with a new feature. I'm going to select, let me do that again. I'm going to make sure these 2 features are selected. Because of that, I want to merge now this into the greater 6204. So I select merge, flash the feature you want to preserve attributes from, and merge. And now we just corrected all 7 of those gaps in, 15 seconds. Okay. I really like this tool, and I think it's a safeguard for those editing boundaries where you're not potentially creating more issues. By allowing the software to do some of this thinking for you, it's going to auto align. You're not going to have, you don't need to use trace. You don't have to use things that maybe not snapping vertices appropriately. So autocomplete is awesome. Definitely recommend it, right? Moving on to the next example, we're going to talk about an overlap. So you can do the same thing for overlap. I'll just demonstrate that quickly. Let's go over to bookmark number 7. And again, if I had my topology on, all of these issues are going to be flagged for me. So I just selected that just to show you the Pepto-Bismol again. I'm going to turn that off though, because I know where my overlap is. And here you go. So I'll select these 2 features. There's my overlap. Let's say I wanted this edge, the one I have highlighted, to align with this curved edge. You can do the same process I just demonstrated by reshaping, creating an even larger area, and doing autocomplete polygon to fill that gap, and then you can merge into this polygon. You can also, and I'm going to jump the gun here, really cool tool. Actually, you know what? I'm going to keep building suspense. So we'll follow the rules. That's just how you can use the tools I showed previously, this reshape, autocomplete polygon, and merge, to also correct an overlap in an ESZ boundary. I'm going to show now the align features tool. So this is a really neat one. I would say we're getting into the advanced stuff now for boundary editing, but this is really cool when you want to do multiple boundary edges at once or multiple features. It doesn't even have to be boundaries. It can grab other features. But it's the align features tool, and the case scenario here is we have all of our ESBs that do not edge match, and we want them all to edge match to be coincident with the ESZ. So let's show that. Oops. Okay, so this one requires a little preparation, I might add. Not the piece up. Like I said, proceed with caution on this one because it is a powerful tool when used correctly. But I'll zoom in here and you can see right now I have all of these boundary edges, and I'll turn them selectable for a second. I have my law boundary, my fire boundary, and my EMS boundary. They're all different from this ESZ, and I want them all to be coincident. So there's a little preparation I'm going to do before I run this process. I'm going to first make my ESZ boundary, or confirm that my ESZ boundary is the only selectable layer, or sorry, snapping enabled layer. And I'm going to actually make the ESZ boundary not selectable. This tool is called the Align Features tool. And you have to have all of the features that you want modified selected. So what I did was I just drew a box around all of these ESBs, and I know that those are the only ones selected because they're the only ones visible and also selectable. So you can come in here and list by selection and make sure it's just those three boundaries. And I only have the ESZ boundary snapping enabled. So what this tool does is it makes you have to draw a traceable line, I'll say it. So once I click Align Features, you can place a point along the edge that you want to be aligned to. And again, notice as I move my cursor along, there's this dotted line drawing. And because I have my ESZ boundary as the only snapping layer, it's going to follow along that ESZ boundary edge, which is what I'm trying to align to. So I'm going to stop my sketch right before the edge of this boundary right here to place a point. Finish my sketch. So when I place that point, notice there's like a buffer here. I can change this. Let's say if I had it at 10 feet, it doesn't quite encompass all of the data that I'm trying to grab here. So you want to mess with this buffer a little bit. I chose, 250. That can be a little sketchy. So I did 25 feet because it encompasses all of these areas. And just know that you can modify the way that this grabs your data. So if I did a rounded edge, you can see here, that can be dangerous because now it's grabbing these areas over here. When you do that, it's going to transform your data, probably not in a way that you want it to look. So I recommend being very careful and zooming out to the full extent of this line that you drew and messing with these a little bit. So you can do just the top part of this road or this sketch. You can do the lower part. I'm doing both, obviously, because I want both sides of these boundaries to be snapped. And then you can square off the end. And I'm definitely going to do that for this situation because I do not want this other edge to be grabbed in my adjustment. Okay, so I have all my parameters set. I'm going to click Align. And there you go. Now, when I turn this ESZ boundary off, all of these ESBs now share a boundary edge with the ESZ boundary. So this tool is awesome, like I said, but you just have to be very, very mindful as you're using it because it's powerful and you can really muck up some stuff if you're not careful. Okay. So that's the Align Features tool. Next, I'm going to talk about one of my favorites. This is the Align Edge. This tool uses a topology, and it can use the map topology. It can use obviously your geodatabase topology, but it also could use the map topology, which again, as discussed previously, is that on-the-fly map topology referencing everything that's within your data, your contents in your project that's visible in your map. So what we're going to do here, this one is better probably demonstrated, but I do want to show kind of the write up here just so it's on the recording. But just the biggest thing to note is the dotted line in this tool is going to be the preview of what the adjustment is going to be, and the solid line indicates what is actually being modified. All right, so let's go check it out. I'll discard those edits. So the scenario here is, turn this off. All of these edges, just like before, are not, I'm going to make this selectable too, are not aligned with the ESZ boundary, and we want all these edges to be matched to the ESZ. So I recommend when you're doing, if you're not going to use the align features tool that I just demonstrated, I would do this individually. So what I mean by that is let's focus on one boundary at a time. So, and I can even pull this to be on top. So the EMS boundary we're going to modify, and we want to clear this gap, and I'm going to show the tool. So the first thing we need, and I'll just demonstrate with the map topology. So this tool is the align edge. If it's grayed out, just know it's because this tool has to be enabled or has to use a topology, and it even says it in the description. This command is currently unavailable. Enable topology to use this tool. If I come up here and I put the map topology, now this tool is an option to start using. So when I click this and enable the tool, something happens with my map where now it's almost like, and I'll kind of zoom out so you can see. Let me turn on some other layers. There's a lot of interactive stuff going on here. Okay. This is a super powerful tool. Again, you have to be, this is like the advanced editing right now. But I want everyone to be aware that wherever there's kind of like a pink outline, it indicates a function that could be performed. And where there's a dot, it's a topology like item. So all these have dots on the end because they're dangles, they're endpoints. It's just something to get familiar with. If you see points along a boundary edge, that's because there's some sort of item here, like gaps and overlaps, which you can see indicating here. So I'm trying to give you a lay of the land of what this tool, how it looks when you start enabling it. So let's go back to our bookmark so we can focus on our scenario. So I mentioned before where there's little dots, it's really hard to see, but there's two little dots on the endpoints here. Those are the vertices of these features, and it indicates there's some sort of topology discrepancy, which we can see here visually. There's a misaligned boundary edge. So this one is just like, it's very quick, and it does not require any pain. I don't have to be in this. It literally is like an on-the-fly validation or topology correction. So here's the boundary I want to modify. It's my EMS boundary. When I hover over this area, it becomes yellow. My cursor right now is on the right side, and the solid line is indicating the edge that's going to be modified. The dotted line is giving you a preview of where it's going to be aligned to. So when I move my cursor over here, see, it changes. So what this is going to do is take the ESZ boundary and align it to the EMS. I don't want that. I want my EMS boundary to align to my ESZ. So all I have to do once I have it set and my cursor is where it needs to be is click once. I do that, and now I've just fixed that topology discrepancy, that map topology, with one click. So let me just show you. We can get really crazy with this. Not trying to freak people out, but I'm going to show you how quick this can be once you get comfortable with this tool. So notice as I hover over all of these, I just turned on visibly these other ESB layers. I'm going to put the ESC back on top. And now it's pointing out all these little areas where there's some sort of topology like issue. You can come in here, and as long as you're paying attention, knowing that the straight line here is the edge I want to align to, I can just start fixing these things. So I'm going to do it, and I want you just to kind of watch. So I'm going to click again. Dotted line is where the edge is going to be changed to. So I'm going to click. I'm going to click. Click. And I just, with all those clicks, I just aligned my 3 ESB boundaries to the ESC. Up here is that scenario we did previously with the Align Features tool. I can also use this to modify my data. So here's an example where you have to be paying attention. I want this piece that jets out to align to my ESZ. So I can choose this and click it, but I also recommend to focus on one boundary at a time. So it's easier to see what you're doing and what you're aligning to if you have isolated features. So let's just say I only want to be modifying my law boundary against the ESZ. I can come in here and correct those discrepancies. And when those little dots are gone along the edge, it means it's fixed. So I can turn that off. I can go back to my EMS and I can do that same process, making sure that my dotted line is aligned with the ESZ edge. Same thing with my fire. And there you go. It's awesome. And again, because it's referencing my map topology right now, this is happening on the fly. So if I were to make an issue, it's going to flag like a new area to resolve because it's in real time validating my data. Here's that overlap that I was showing earlier that I did not resolve. I can also use this tool to fix that overlap. So once I stop using this tool, you'll see your data updates. Make sure you save your edits. But hopefully you're getting the gist of this. It is super powerful and it makes editing so much more efficient. And that one was the Align Edge tool. Okay. All right, we are in the home stretch here. What I'm going to do before we move on to our final example, let's go back to the PowerPoint, and I want to talk a little bit about some workflows. So the suggested order of corrections is you focus first on getting those boundaries aligned. So this is our suggested order. I got my nice little visual here. Start with getting the PSAPs, gaps, and overlaps fixed, which, hey, you know, the state manages that for you, right? If we already know that you can go to OK Maps and download a compliant data set. Right? I shouldn't say compliant, but a NG911 formatted clean PSAP boundary for your PSAP. But you still need to develop fire law, EMS, and ESZ boundaries with proper internal boundaries, so no gaps and overlaps. That's where you want to start because a lot of these roads are referencing the attribution of those other boundaries. So then you can move into correcting your road centerline topology and, you know, fixing some of the items we worked on earlier, making sure that the intersections are all represented properly, multi-part segments are exploded and individual, and of course, the dangles, making sure those are snapped properly. Then once you get your baseline geometry for your roads and your boundaries figured out, you can then start comparing those features against the boundaries. So that's where you want to start splitting and snapping your roads to the boundary edges and also comparing your address points to be properly contained within them. So this is all so far in relation to your individual PSAP boundaries or your PSAP data. Then once you get your PSAP data corrected and compliant and pushed up into the repository, then you can start comparing your data to your neighbor data. And we're going to walk through an example of that. But that's kind of like phase 2. We're in phase 1 right now where everybody is pushing their data up into the repository, getting it to a certain quality standard. And then we're going to start expanding outside of your own PSAP and comparing your data to your neighbors. We talked a little bit about this already, but exceptions within a topology does not translate to the exceptions in the topo accept field. What an exception means is that the real world, the data reflects the real world. So there's no real adjustment that needs to happen. For the new standard version 3, really the only acceptable exception value now is dangles. Yes, you get all these options, but if you think about what the toolkit is flagging, and we talk a lot about this in the toolkit class recording that we did, but you really shouldn't have roads be an exception of being outside of a discrepancy agency boundary, or an address point being outside of a discrepancy agency boundary. Those really should not be submitted for your PSAP. So they wouldn't really be an exception, if that makes sense. They just need to be marked as a no for submit if they are outside, or you need to reconsider how your boundaries are drawn in order to properly encompass the data. Okay. We talked a lot about the editing tools already. We demonstrated in the class exercises split, explode, edit vertices, reshape, align features, and align edge. But there are a bunch more that, depending on what you're doing, you can research and start using. But I wanted to demonstrate the most common ones to correct topology. Now, let's go through the final example I have here on my exercise. And it's really more of a discussion point than an example. But so again, we're in phase 1, which is aggregating the data as a statewide data set, pushing it into the state repository, and having a statewide complete address point, or really just NG911 data set. That data gets pushed into the repository, which is hosted on the OK Maps website, which is linked here. And you have the ability to view and download data. We talked about this earlier in the recording, so I'm not going to spend too much time. But here is the OK Maps site. You can go to the public safety group, and then you can download the data directly from here. This is going to be the data from the last upload that your neighbors or you did into the repository. So it's in real time. It will refresh. As soon as somebody uploads and it's successful, it will be reflected in this data. So as discussed earlier, you can download by downloading directly from that site. It is going to package up a geodatabase of the statewide address points, road center lines, and PSAP boundaries in WGS 84 projection and in the Oklahoma standard schema. And from there, you can pull that data into your pro map and start comparing against your data. We talked earlier about adding the web map service to your pro. You would just grab that service, add the server, and then connect there. And that would be a live feature service. So let's talk about this example, comparing your data to the state downloaded data. So here could be, this is going to be an example workflow. So let's go here to bookmark 10. I am on the edge of my boundary, and I downloaded this data from OK Maps. It is a large data set, and I'm just gonna, I have it already represented in my data, but you can see this is the format that it comes back within the NG911 feature data set with these 3 layers, all representing the statewide data. And I have it already pulled into my map here. So I'm going to just turn on the roads and I'm going to zoom out and you'll see what this looks like. So there you go. There's the whole state of Oklahoma from this date stamp, the aggregated road centerline layer. So you can imagine that's a lot of data. I'm going to zoom back in here so we don't crash the map. But how you're going to want to reference this with your own data is, of course, we want all of our roads to be snapped across PSAP borders and boundaries as well. Of course, like your boundaries should all be aligned to your provisioning, or sorry, your discrepancy agency and PSAP boundary anyway. But you know, and that should be across borders where there's no gaps and overlaps. But let's focus here on the roads. So like, let me turn this off so we can see. Right now, maybe I should have this up here. Okay, so my data is in orange, and then the statewide data is pink. So you would want to coordinate with your neighbors, of course. That's step 1. But you're going to want to modify your road data to be snapped and consistent across the boundary. So I'll turn on my imagery so we can see what's going on here. It's always good to get a idea of where the true feature should be represented based on imagery. And from this, it does look like my road is actually offset. I think it would be more appropriate to take my segment here and snap it up to my neighbor's data because they seem to be more in the center line. So you can just kind of assess the situation, come in here, maybe you edit the vertices, you know, you can take both of these, come over here, snap, make sure snapping is enabled. You're going to want to start kind of correcting this way. And then my road currently is outside, so I'd want to make sure this is traced and maybe do the offset pinch point parallel along this border. And then my neighbor is going to have changes to their data where they're going to take their segment, offset it into their PSAP, and have parallel, and they both will come together to snap at this intersection point. So you can imagine this is a lot of work and it does require a lot of coordination. And that is why this is really important to be referencing. But remember that this data is only as current as the last time your neighbor uploaded into the repository. So knowing that, yes, it is required quarterly for everybody to be updating and uploading their data, but it's still really important to communicate to your neighbor and say, hey, I am going through an effort now of snapping my data to yours that's in the repository along the edge of our 2 PSAPs. Please don't modify your roads. I'm going to make sure that I snap mine to yours, and then we all upload to the repository so we can see how things are consistent and starting to become more of a cohesive data set. So again, talk with your neighbors, talk about your plan. Even if you were to do your roads first and get them in place and say, here, I'm good. My data is good in the repository. Now you go ahead and reference my data because I'm confident that my topology is accurate. And then, you know, there's that coordination effort. And now we can proceed into the workflow discussion. Okay, so we are in our final stages. We're going to navigate into the workflow discussions. And the first discussion we want to talk about is downloading the statewide data from OK Maps. So, you know, we've talked a little bit about this already, but when you have submitted your data to the state repository, it gets added into the repository, which is like an aggregation of statewide data, and that is hosted on the OK Maps website for public download. So right now, the expectation is everyone needs to get their data submitted by June 2026, and then and that is in version 2 or 3. And by October, everybody must be migrated to the version 3 standard, which is using the Pro toolkit. So that data is publicly available, and when it comes to understanding your workflow, you're going to be remediating your PSAP data to get it pushed into the repository, but you also need to consider how your data aligns with your neighbors. So by downloading the data from the state, you can pull that in, as we already showed, and start working and coordinating with your neighbors to create a seamless data set. So snapping those roads, aligning boundaries, although the state does manage the PSAP boundary. So, if there's adjustments that need to be made, there's a communication pathway for that. So I'm gonna just open up the OK Maps site and we can navigate what that looks like. So here's the website, okmaps.org. Here's the interface. Now, if you navigate over here on the category side, there's a public safety, and you can currently add layers for version 2 and version 3 into this visual map. So if I wanted to add the version 2, you expand that and click add to map. And there you go, there's the statewide version 2 data set. Now, this is refreshed as people upload. So it is not like once a quarter this data gets reflected. It is instantaneous with the repository. So if somebody's submitting their data, it's going to be reflected here. Now I'm going to take that away. We also have the version 3 available, so you can see this is going to be less complete as people, right now there's a big push to get everybody in, and really version 2 is what most people are submitting. Just keep in mind as you think about workflows, comparing your data, depending on the version, people may have not have submitted in this yet, so you won't have access to that data, but you can always go to version 2 and make sure, because really this is for geometry, it's not attributes right now. So there's that, and then if you want to download the state data, you can just simply click this download button and it'll create a zip file, a geodatabase, and it will, I know you're, right now I'm in the address point, but when you click this download, it will include the entire address point, road, and PSAP boundary layers. And that was intentional just to make sure that, things aren't being downloaded at different dates and you're having mismatched data. So when you download one layer, everything comes down with it. So that's really accessing and pulling down a stagnant piece of the statewide data to pull into your local map. Annie, was there anything else with just like the edge matching we need to talk about, or anything else you want to add with that repository data?
Not on the repository side.
So that's the process if you want to download the data from OK Maps. But there is an option if you want to have a feature service pulled into your map. So in order to do that, you need to, in your ArcGIS Pro, you would add a WFS server connection. You can just search that in the Pro search bar. I'm sorry, you would do that through a server connection. And then in order to access the URL for that, you need to come in here on OK Maps. Down here, there's the WFS. There's also a WMS, so Web Mapping Services or Web Feature Service. And you'll come down here and expand the ArcGIS desktop, and you can grab the URL here. If you do the WMS, you click that link, and there's the server right here. So you would just take this URL, and that's what you would throw into the tool URL right here. So once you do that, you have your server connection added, and then the layer you can add the layers to your map. And then from there, it's a live feature service. So as the repository gets updated, those, when you have it added to your map as a service, it's going to automatically reflect those changes in your map. So that's kind of nice. And we talked earlier about map topology. This is one of those use cases where having the map topology reference data from different data sources is really helpful, because this is pulling from a service. You have your data locally in a geodatabase, let's say, you can compare those two data sets together, right? We'll say be mindful as you are editing data with different projections, maybe the data that is created by the toolkit and the data that's hosted within the OK Maps site is all going to be in WGS 1984 projection, which is the NG911 required coordinate system. But if you have like an SDE environment that's in maybe a state plane coordinate system, just be mindful of how you're editing data when you're comparing different data sources and keeping things in the same projection. And then the final thing I'll say here, when around a workflow for comparing your data to the statewide data, is it doesn't take away the coordination with your neighbors, because they may submit their data once a quarter, and you just want to be sure that the data that you're referencing to maybe do your road snapping or edge matching is as accurate and current as possible. So it doesn't hurt to reach out to your neighbors, find the contacts for who's managing the GIS data, and say, hey, I'm planning on snapping my data to what's currently in the repository, just letting you know, don't go through this effort. And there needs to be some coordination is what I'm trying to say. All right. Annie, we can talk annexations now.
All right, everyone's favorite topic.
Your favorite.
Yeah, not really. Annexations, actually in Oklahoma, they are a good topic, and that's because you have some really good statewide guidance for managing annexations. So, annexations are really about when a city decides that they want to expand their tax base, and so they can annex land from the county. You can also have de-annexations where land is given back to the county to remove them from the city's tax base. And so while those really pertain to municipal boundaries, even though municipal boundaries are not required for Next Gen 911, they are very important for the data management. So where the data management is concerned, anytime, and I think we've talked about this earlier, anytime that you have a road center line that crosses a boundary, or where you have an attribute change, um, you will need to make sure that that's reflected in the attributes. So if you're going from unincorporated into a municipality, you'll need to make sure that you update those values, not only with the road, but also with the address points. And if your municipal boundary change results in a PSAP boundary change, a change in the call routing boundary, then you will need to go through the process to make sure that you are providing those updates as outlined in this PDF. So Beck, I don't know if you want to click on this real quick just so we can show. All right. So this is the boundary change request form, and you'll notice that the whole process is outlined here. So basically, if you need to make a PSAP boundary change, you have to get together with your neighbor. And remember, these are 911 coordinators decisions or 911 authority, not GIS decisions. GIS people, you can make the map package, you can make the map that they use, but ultimately this has to be the PSAPs making the decision. And so basically both parties need to agree on the changes that are occurring. A a spatial file needs to be provided that shows what the change is. And then all of that has to be set up to the Oklahoma Emergency Management um, address that's all listed here. And if you scroll down, the PSAP boundary and the actual annexation, is it just the one page? page 3 of 3. Oh, so if you scroll up, yeah, I think the PSAP,
Oh, did it?
this is
Oh,
the second.
oh, I
Yeah,
see.
so this is the one that's annexations and it's in the same doc. So annexations and de-annexations, that process is here. And it like as we just looked at, the PSAP process is on the next page. So that's these are the guidelines that you're going to use to guide that process, whether you have to do an annexation or a de-annexation, or you need to make a change to your PSAP boundary. And I just kind of simplified that on the graphic that's in our PowerPoint, because that it's actually really nice that you guys have that, because a lot of states don't, and it gets ugly really fast. So while municipal boundaries are not critical for NG91 call routing, they are important because they do impact not only the attributes, the city values, the municipality values, but they also may impact the actual PSAP boundary if that's the expectation. So just make sure everyone's communicating and documenting everything and following this process, so the state gets the latest and greatest updates. All right, so when we are adding new features for addresses and roads, there are some things that we want to be mindful of during our editing process that can really facilitate and help us, what before we run our topology, right? Because a lot of this should be preventative so that we're not creating errors for us to fix later on. So for addresses, we want to make sure that we are not putting address points on road segments. We are not putting address points on boundary edges. If you see that a boundary goes through a structure, my recommendation would be to have a boundary workshop. I know it kind of seems like a lot, but I would encompass the parcel in which that structure is located and make sure that you are making the appropriate edits to that PSAP boundary, with the understanding that your neighbor agrees, and that they will also change their boundary to match. You want address points to be completely within. Remember, we should not be provisioning or trying to provision anything that is outside of our um, discrepancy agency boundary. So, and as we mentioned just a minute ago, that the attributes of the addresses need to match the boundaries in which they are located. So the PSAP boundary, the incorporated municipality, the county, and the ESBs. All of those are values within your GIS data. So you want to make sure that, from a geometric standpoint, yes, the address is fully contained within the respective boundary, but then you're also making sure that the actual attribute values match. For road center lines, you want to make sure that your roads have proper intersections represented. So if it's a true four-way intersection, you are snapping and splitting at those intersections. Make sure that roads are digitized in the direction of increasing addresses. Okay, that is the NENA standard, that your road center line is digitized in the direction of an increasing address, and that is for public safety. Um, the roads that have to be properly snapped and broken and fully contained within the boundaries. I know a lot of folks manage regional, road center line data sets that extend outside of their PSAP for response. In real life, our maps don't just drop off at the edge of our boundary, okay? However, you want to make sure that the roads are split at the boundary, and that anything that's outside of the discrepancy agency boundary is attributed with an N for submission, because you don't want to submit those roads that are outside of your boundaries. And also, the road center line segments need to match the boundaries in which they are located, just like the address point. So the PSAP boundary, if they're in an incorporated municipality, county boundary, and the ESBs. And I don't know, Becca, if you had anything you wanted to add there.
Oh, I think just, well, getting familiar with the standard, really understanding your own workflow on what to be mindful of from an attribute standpoint. Obviously understanding what's mandatory in the schema. I mean, the more practice and familiar you get with the standard in general, it's really going to help you. And of course, uh, with the toolkit, practice is necessary, because you're going to get more familiar with what's going to flag as an error, and really start to proactively, like you said, understanding what could be creating issues, and that's just going to help your efficient workflow in general. So,
Yeah, and I also think that understanding in advance, like what the required fields are for the toolkit, um, is also going to be helpful. So, I think we had mentioned in the toolkit class that you guys really should keep that schema document open that you can download from the state's website, either that or the standard, just something that helps you kind of cross check and double check, because it might be difficult initially for you to make sure, okay, it's like, do I have the right PSAP? Check. Do I have the right municipality? Check. Is my county boundary correct? Check. So that is a good way of just having that extra checklist, I guess you could say.
mm,
And I think it's going to be really valuable. I think as you run through this a couple times, you're going to start to become more familiar, and it's going to really be second nature the more you do it. But initially, you might have to keep bouncing back and forth through the documentation, and not only that, either the standard or the Excel schema that we showed in the toolkit video, but also the README for the toolkit has some field information and values in it as well. So those are some helpful resources. Okay, so as far as boundaries are concerned, you know that the state manages the discrepancy agency and PSAT boundaries. So, of course, there is a process for those. You should be reviewing those at least annually. If you have a lot of development going on in your communities, especially if it's along boundaries or if it extends outside of boundaries, I highly recommend that you review those on a more frequent basis. It really just depends on what's going on in your community. If you're super rural, a lot of farms, nothing going on, I would say just an annual review, just to kind of check off and make sure it's okay with your neighbors. But some of you will need to dive into that in a little bit more detail and do it more than once a year. So that's my first point about those two boundaries in particular. But as far as boundaries within the same feature class, you don't want to have gaps and overlaps with your ESBs or your ESZs. Okay. So make sure that, those boundaries are adjacent and congruent. It's a best practice that boundaries do not share edges with the road center lines. Generally, we do recommend that you slightly pull the roads off of the edge, or that you utilize an offset to make sure that it's fully contained within the appropriate boundary. And I think in the exercise, we did show you how to utilize those pinch points to easier offset those road segments. For boundaries that cross different feature classes. So you want to make sure that where boundaries follow the same edge, they are aligned appropriately. So making sure that they are congruent, no intentional gaps and overlaps. They should be fully contained within the discrepancy agency boundary. Again, think of this discrepancy agency boundary as a cookie cutter. Anything that's outside of that is going to be cut out and ignored. Okay. And also you can't have any, I guess you would call it, gaps between like your ESBs and ESZs and the discrepancy agency boundary. So you need to make sure, kind of like, you're coloring, the thinking like the Scantron bubble, you got to get all the way to the edge, right? So make sure that your boundaries are really going up to the edge of that discrepancy agency boundary, so that you don't have any areas that are no coverage. And they absolutely should be edge matched. And we're, showing you lots of good examples in the exercises there. So boundaries across PSAP borders, I don't know if this is going to be relevant for a lot of you, but you want to make sure that they are edge matched. And for road center lines, they need to be snapped to the neighboring road network for seamless connectivity. Because remember that the end goal is to patch all of these together like a quilt, which is kind of how the repository functions. And right now, there are no like cross jurisdictional type checks and balances between PSAPs, But that's why it's even more important for you to have these conversations with your neighbors so that you can make sure that at least where your boundaries are concerned, that you are appropriately edge matching and snapping to the neighboring road center line network. And Becca, I don't know if you had anything to add for boundaries.
I think you covered it.
All right.
Okay.
Oh yeah, snap twos. Yeah, we just kind of mentioned this, right? So you want to make sure that again, communication is key. So making sure that you are communicating and coordinating with your neighbors. So in the top graphic here, we show you an example of where some roads are slightly offset because they're not snapped to each other. So you want to make sure that you are snapping to the neighbor, and it's like, okay, well, who's correct, right? It's really a lot of times it's just super marginal, as long as you're kind of like in the right vicinity. It's the connectivity that's super important, not necessarily how it aligns on the aerial, because there are minor differences with aerial photography. Even year to year, even if you have the same company fly, you're going to see some differences in how that imagery is processed and displayed. So just make sure that for the most part, you have solid connectivity between your own road center lines and your neighbors. And as far as the PSAP boundary snap twos, so as the road leaves the PSAP boundary, you're going to split and make sure that your road is snapped to your PSAP boundary, but then your neighbor will also snap to yours. So, and I think Becca, we went through an exercise, correct, with this one? Okay,
Yep.
got it.
That's kind of what I was saying earlier when you download the data from OK Maps. It is going to be updated based on that PSAP, your neighboring PSAP, when they last pushed their data into the repository. So it could be a couple months old, and that's where that coordination is really important to at least let them know what your plan is. Maybe even creating like a point layer that everyone snaps to. There's
Mhm.
going to need to be some coordination across these borders.
Absolutely.
It's just a good example. And I can kind of talk through this because this is really similar to the previous examples we walked through in the data. Coordinating across PSAPs, there are going to be cases where both segments need to be represented in the data depending on the data within your individual PSAP. So this is a really good visual of where you can see here there's two streets, 71st Ave, in both data sets. Sorry, 71st Ave that represents both sides of the road, I'll say. And you really want to be able to offset the data to be fully contained in your PSAP, because that is going to be the requirement. And the segment that represents your address points will be what you submit. So I'll just pretend that I'm PSAP A in this scenario. If I have address points in over here that represent or that correlate to 71st Avenue, I need to have this segment in my data, right? And I'm going to want to submit it because it's within spatially my PSAP. If I still need visually to have this segment, this red one, in my data set for maybe other, like my CAD, or just to have visually represented, that's fine. You can offset it to be outside of the boundary, but it would be marked as a no for submit because it's not a segment that I am responsible for provisioning up to the state. PSAP B will include that in their uh, puzzle piece, I'll call it, in their aggregation. So that's where the submit yes and no can be really handy, where you need the data represented geometry wise, but you're not necessarily wanting it to be linked to your PSAP in the repository. And that's where the pinch point method is really helpful here to eliminate the overlap of roads across data sets. And I think I don't know if there's anything else besides what we've already covered, Annie, that we want to explain here. I think this is a good just visual,
Mm,
but
yeah, I think we covered it for the most part. I'm sure this brings up a lot of discussion, and I guess I would encourage folks because this can be a little bit confusing. So I would definitely reach out to Shelly if you have any questions about this, and the state can give you further guidance. This is where being in the physical class is actually really beneficial because there we've had a lot of discussion about this because I think a lot of people they don't really reflect on the attributes as much as they should, right? It's like we're busy checking off the boxes to make sure that we've got what's mandatory, but these other things have meaning too, especially for um, the maybe the fields that are not required, but are still used in the tool runs or the submit fields. When is it appropriate to use those? And especially with the changes in the most recent toolkit, I think this is going to bring about a lot more questions. So I would definitely reach out to the state folks if you have questions, because we've had a lot of extensive conversation in the in-person classes about these examples.
mm, yeah, it's always good to have real world examples to talk through because it truly needs to have a solution. And I know as everyone starts to clean up and remediate their data to meet the version 3 requirements, like you said, there's going to be some unique situations where we may need to get a little creative in how you represent this data, but that's why, we're suggesting, of course, reach out to your contacts and reach out to the state because they're really good at helping kind of walk through this and find a solution. Okay, on we go. Best
Yeah,
practices. Let's talk
best
about them.
practices. All right. So Um, you want to make sure, just a very simple, it's gotten us a few times. You want to make sure that your geodatabase is not within a folder that has a .gdb extension, or the topology will not work. That is um, easy to have problems with, but just removing that extension should make things start functioning again. So, as usual, make sure that as you're editing, you need to make sure about how features impact the attributes, right? So when you do splits, um, be mindful of the things that you need to adjust within the attributes. It's remember, you have to look at this stuff holistically. The GIS is geography and information. So as you're changing the geometry of the geography, you want to make sure that you're also thinking about how does that information get represented in the attribute tables. Things like a road range, they don't get updated automatically. Okay, so you need to make sure that you're updating your road ranges. You want to make sure that you are thinking about your NGUIDs. You want to make sure that you are updating the community values. I don't know what else am I missing for road centerline updates for the
Oh,
attributes and editing.
you said ESN, MSAT community,
Oh yeah.
PSAP left and right, even the
Hmm.
topo accept. Oh wait, yeah, if you're like splitting roads and
Yeah.
one segment needs an updated value, submit fields even, depending on what you're doing. So yeah, anything that needs to stay unique to that individual segment. I mean, most of the time, like county values, obviously state values, like those aren't going to change for the most part, right? Um, yeah.
Yeah, I would almost say that until you get super used to this, like when you split a road center line, you almost need to treat that like it's new, like it's a
Segment,
whole
yeah.
new, and just go down the list. Like look at your attribute table as a checklist, and you're
Yep.
just sitting there verifying everything against the other layers. Um, because like I said, there's a lot of stuff that don't update that do not update automatically. So, you want to make sure that you're going through and really paying attention to what you're doing. Um, Make sure yeah, confirm the projection when you're editing between feature classes. That's always a good idea. And I think that's great for, a map topology. If you're using a geodatabase topology, of course, everything's going to be in the same projection anyway. That's how the toolkit builds it when you go through that create geodatabase. Um, Turning off or disabling the editing on the layers you're not modifying is
Mhm.
really important. And
That'll
like this
help
was
you.
something, listen, I mean, this is something that I even did a long time ago. And even the earlier versions of like ArcMap, because I used to sometimes edit things and I'd have a lot of stuff turned on. I'm like, wait, why does that look that way? And it's because I didn't have stuff turned off. So anyway, it
Think
just
we've all
makes
like
yeah.
grabbed an entire data set and shifted it accidentally, not
Yes.
knowing
Yep.
at some point.
Shifted it, or like you
Yeah.
look and it's like, wow, I just cut out like, whole chunks of parcels of what's happening. So yeah, just be very careful about that. Um, Use the symbology to help display discrepancies. That can be super helpful and help you retain your sanity as you are editing your data.
Mhm.
Oh yeah, the spacebar trick. That's a really good one. That really helps when you're working through snapping, as Becca showed you during the exercises, and then using that T key. So basically, like the shortcuts are very beneficial in editing. And unfortunately, I don't get to do a lot of editing anymore. So Becca has all those little tricks up her sleeve. So if you want to add anything here, Beck, you go right on ahead.
No, I think this summarizes it. Actually, you know what? I do want to mention on this first bullet, it if you know this is like a pro thing. This has nothing to do with the toolkit or anything. It's something that we've noticed when using Pro more often, when it's embedded in a folder that has a .gdb at the end, other functionality won't work as well. Like even trying to remove a feature class, like deleting a feature class from a geodatabase, it just won't work. So this has tripped me up like a handful of times, and now I'm starting to realize, oh yeah, I have a .gdb. Let me delete that before I even start trying to do any data management processes. So um, that's kind of a new one. I think another best practice that we've been harping on in all of our videos, but refresh your geodatabase, refresh your folder in catalog. If you're not seeing a process or a layer or something that you're expecting to see in the folder structure, I bet you a refresh is going to solve that problem for you. So there's some
Yeah,
things, and
I've
it you kind of get tripped up and then you learn.
Yeah,
So
I mean, I think while Pro has improved in many ways, nothing is perfect. So,
yeah.
you might have to refresh, or I've even had to close the program and open it up again. So it's not as buggy as Map, but it definitely is not perfect. So,
It'll still crash out on you. Don't think you're getting
yes.
away from that.
Yeah, I think that's like a nostalgic kind of, it's like we can't make it too good. We have to put some of this crashing in here for the people that are still attached to ArcMap. So,
Exactly. Make it
anyway.
feel like home.
I know, exactly. It's like, oh man, I've lost 3 hours of editing. Great.
Yeah.
Um, Anyway, so topology kind of falls within that creating a QA culture that we've talked about for literal years. I mean, I don't know that I've gotten through any type of class in Oklahoma without talking about this. So, quality, QA QC is really a part of any solid workflow, and it is a requirement for next gen 911. It's just the topology is just one of those checks. So when you look at the toolkit class and you're looking at the validations, the topology run is just part of the outputs, right? So that's one of many things that is enforcing the quality and the best practices of your data management. And it's really going to illuminate the things that you didn't even know were there within your data because maybe you couldn't see the dangle with the naked eye, right? Like you have to zoom in, zoom in, zoom in, and it's like, well, oh my gosh, I didn't even see that there because I wasn't zoomed in enough. So really leverage the topology tools because they can help you tremendously. um, you may need to engage different stakeholders depending on who's managing the data in your locality. Many of you are going to be fortunate enough to be the master and commander of all the NG91 data, but there are a lot of people who don't have it that way. A lot of counties have split data management, right? So if you're in a planning and zoning office, and you are managing the addresses and roads, or you're just managing the addresses, right? Like those people need to be engaged in what all of this stuff means. So if they're routinely placing addresses on roads, I don't know why they would do that, but planning does wild stuff anyway. But anyway, depending on what the situation is, you may need to engage these different people. Um, to really help you with the data management, right? And it's also understanding, who manages the data and what are they using it for. We know that improving the quality of data for NG 911 really improves the data quality across, basically the entire government enterprise. However, there are some things for which this data may not be appropriate. So, for example, if you are managing linear referencing system and you need that for something in your county, or whatever it is, um, this may not work for you because of all the splitting, right? So you're just going to have to figure it out. And I think for most of you all, because this is going to be a transition and not like a whole new thing, I think a lot of you hopefully already have your workflows down. Whether or not you're in an SDE, that's going to make a big difference in a lot of these. It's like, okay, I have to figure out how to get my topo accept field um, managed up to my default so that I'm not having to do topo mark through my topo accept. Can you imagine in a huge locality if you had to mark, 1,000 cul-de-sacs as, no dangles? Like just getting that workflow in place is hugely important. So making sure that you've got your workflows, and you may need to make changes or adjustments to your workflows given this, and I guarantee you with some of these new checks that are in here, you're going to have to make changes to your existing workflows, for sure, especially with the ESDs. Um, Understand that this is not a one and done. You're going to have to do this at least quarterly. But again, if you're doing more editing, you're going to have to run it more frequently. I don't know, Becca, anything else to add here?
Yeah, I just want to mention this is a never ending thing, right? GIS data management is going to be, especially for public safety, is going to be forever, right? So like it's not a one and done. It's going to require a good workflow, SOPs, integrating the toolkit validations into your, weekly or monthly process. And also that we are in the aggregation phase, but eventually there's going to be the comparison of your data with your neighbors and in a next generation core services provider environment, which may have other requirements, right? So there's constant evolution with public safety, especially as NG 911 continuously develops and new standards are being pushed out every couple of years. So I think creating that QA/QC culture, developing your workflows, and really just setting yourself up for success is how you want to approach it.
Mm-hmm.
Easier said than
That's
done,
the
but
way.
you know.
Yeah. Yep. Exactly. But I think, this is a good start. And I would definitely start by downloading the newest version, just going ahead and getting into it. And hopefully you guys have your workflows documented, because you're going to need to work through the new version and see how things have changed and then make your updates accordingly.
Right. Well, is there any final words before we wrap up?
Good luck.
Yep. Good luck. And that concludes our topology course. Hopefully those tools work for you. And as always, if there's any questions, we're always here. There's great contacts at the state. Shelley Willoughby will be the contact for anything toolkit and repository wise. But good luck, everyone. Thank you.